Yeah. So in Kafka, we do have something like brokers. These brokers are basically going to manage the topics. So this topics is a place where we actually store some data. And Zookeeper is the base for running Kafka, because if Zookeeper is not there, a Kafka will not run. So Zookeeper basically serves as a distributed service for Apache Kafka, but Apache Kafka is a distributed streaming platform. Okay, and the Zookeeper is basically going to act as a distributed service for Apache Kafka for managing the broker registrations and all this kind of things. So brokers are the kind of the mediators where it will where they will actually produce and consume the data. Okay, and it also ensures coordination and synchronization among brokers in Kafka cluster, because I said, right, inside the Kafka cluster, we do have brokers. We do not run one single broker. We do have multiple brokers. Okay, that is to actually, support fault tolerant mechanism, because even if one broker is down, the data is still being served from other brokers as well. Okay, so here this is a Kafka template. This is just like a CRUD repository or the JP repository, where it will have some configuration information inside the application.yaml. And then probably we do have something like the Kafka template, which can be used to send the data to a Kafka topic. Okay, so here if you can see, the first parameter is the topic name of the Kafka, and the second parameter is the data. We will see that in practical now. And here this is a Kafka listener. This is basically going to act like as a consumer, where it is continuously listens to payment request topic. That means once the data is arriving inside the payment request topic, the consumer will take the data and proceed accordingly. So that's the end of this presentation. Okay. So I think, Akash, it was very fast, but I will be explaining all these points maybe in practical. It will make a lot of sense to you. Okay. Okay. So everyone able to see my screen, first of all? My screen is visible, right? Okay. Okay. I don't know why it is showing not now. Okay. Okay. Thank you. So is it visible now? Yeah. Okay then. Okay. Yeah. So now I'll just close this and we will proceed accordingly with the code. Okay. So now yesterday we have actually, written some configuration data, but I will be trying to explain all those things in detail. So let me go to the infrastructure module. So here, Akash. So here we do have something like two services to run. One is a Zookeeper. So here, this complete configuration, I have not written it because this configuration is obviously provided by the Confluent organization in their GitHub account. So they have actually given these services. So I have just taken that service from the GitHub account, and then I have actually placed it over here to start the Zookeeper, because Zookeeper is the main server where Kafka requires Zookeeper in order to run. Okay, so this is the image to run Zookeeper, nothing to do with that. Okay. So this is a Kafka cluster. So we do have a schema registry, just like Eureka server, where it actually acts as a registry for all of our microservices. The same way here also we do have a Kafka cluster. And inside this Kafka cluster, we do have something called a schema registry, where it actually registers the brokers. Okay. And it will have a complete information about the brokers, which broker is down and which broker is up and all these kind of things. So this information will be provided to the topics. Okay, so here we do have broker one. It is basically on 19092. Okay, it is going to run on 19092. And here we do have Kafka broker 2, which is running on 29092, and here 31092. Okay, so why these brokers? Because brokers are basically going to control the topics and the storage kind of things in Kafka. And here is a Kafka manager. This is basically a UI where we can actually see the created topics. Okay. And this is exposed on 9000 port and it requires Zookeeper host in order to run. Okay. So that's the only thing. And this is a simple sample script. You don't have to worry about all these things. This is just to create Kafka topics inside the Kafka cluster. So let me run each and everything. First, you need to run Docker compose -f because there are so many files over here. I need to run this Zookeeper first. So Zookeeper up. So let's wait for Zookeeper to up and make sure that you have a very good internet connectivity. I have already downloaded Zookeeper. The image was already downloaded inside this Docker. So if you just go to the images, it is already there. So if you see there's 779 MB, 779 MB. This is almost equal to 1.4 MB. And this is a schema registry. It is almost 1.64 GB. And this is it is almost equal to 2.5 GB completely. So 2.5 GB in the sense, these are Docker images. But if you just wanted to install Kafka in your machine, it requires a lot of space. More than this, more than 2.5 GB it will consume. And installing Kafka on your local machine is not recommended because we always use Docker images instead of installing the softwares. Got it? So that's the total idea. And let's go forward. So now the Zookeeper is enabled. That means the Zookeeper is up and you can see the container. The Zookeeper is almost up and running. Okay. Now I will just go to this infrastructure folder again and clear this. Sorry. And I just wanted to do Docker compose -f. And we do have something called a Kafka cluster YAML and up. So this is basically going to, run the Kafka broker schema registry and the Kafka manager. Let's wait for some time until it runs continuously, and then probably we can access the Kafka manager, which is a UI. If you just go to the Kafka cluster, we do have a Kafka manager where we can actually see the UI on localhost 9000. Okay. And we need to create the topics also because I have deleted everything. So we need to recreate the topics again. Okay. So Akash, don't worry. I will be repeating the topics once we are into practicals. Don't worry about that. And I'm saying don't miss classes because from this time, the classes are really important. I don't want anyone to miss any of the sessions. Okay. Yeah. Now Kafka manager is up and I can actually go to the localhost 9000 and I can see the Kafka cluster over here. Okay. So since I have not created the Kafka topics, let's go and create the Kafka topics. We need to run the script again. So here I can just go to the infrastructure and then clear this. And now I can do Docker compose -f init Kafka up. So basically, this is a script. It will just create the topics on the fly and it will delete the existing topics if anything is there, and it will create the topics, the payment request, and the payment response. So once this is up and running, this does not have to up and running because this is a script. It will just create the scripts and it will go on the fly. That's it. Now just go to the cluster. Just give some add cluster. So give the cluster name as movie ticket booking system. And the Zookeeper, if you just see the Kafka manager, the Zookeeper host has been given as Zookeeper:2181 because that is the service name that we have created and we cannot use localhost. Okay. So here I can just give this Zookeeper and then probably I will just save this information and go to the cluster view. And here you can see the topics, the payment request, and the payment response topics. Okay. So here we do have brokers, 3 brokers for each and every topic, right? So there is one broker, which is for payment request, the second broker for payment request, and third broker. Why we are maintaining multiple brokers? Here brokers are instances. Let's say the first broker has been crashed or the second broker is crashed. Then probably whatever, see initially we have actually, if you just go to this init Kafka, we have actually said that the replication factor as 3. Okay, the replication factor 3 means it has to create 3 different brokers. And if you see the Kafka cluster, we do have 3 different brokers. It's not a good idea to, maintain a single broker, because what happens is, let's say if one of the broker is down, this Kafka cluster will make that broker again run in the same stage. Okay, it will not make the whole system as down. This is for high availability. Okay. And here I have given the partitions. I will tell you about the partitions maybe later on, but let's continue with where we left yesterday. Okay. So here, if you just go and see the source main resources, here we have actually configured the Kafka producer bootstrap servers. So these are the brokers and the key serializer and the JSON, the string serializer and the JSON serializer. Why I have given this, right? So if I just go to my Kafka publisher, I have not written any code. Okay, so today we will be writing the code to publish the message to the Kafka topic. Okay, so now what I just wanted to do, booking service. So yesterday, Akash, we have actually removed the complete code over here inside the booking service IMPL. If you just go over here, we have just removed everything. There is a lot of code over here. After this pending, we were calling the Stripe payment gateway through the payment service, right? So here what I was doing, instead of calling the payment service and waiting for the response, I'm simply returning booking DTO with the pending status only as a response. But there is another API which I have introduced over here, and that API is basically a tracking ID to track the booking ID. We'll get the booking details information, whether it's confirmed or rejected or whatever it is. Okay, so that's the total idea. And here, yesterday I have actually written this Kafka template, because this Kafka template is just going to act like as a repository. Okay, so why repository? And if you just go over here, you have actually seen that I have actually given data source, URL, username, and all this kind of things. Let me paste this on top over here to segregate everything. Yeah. So here, without this information, our CRUD repository or JPA repositories will never work, correct? Like the same way, since booking service is now acting like a producer, because it has to produce the data to the payment service, right? That's why there has to be a producer with this particular string serializer and JSON serializer. What is the string serializer and JSON serializer? So string serializer is a key serializer, and JSON deserializer is a value serializer. Okay. Now, why I have kept this kind of things? Okay. And if you just see it over here, this is a Kafka template where the key is string and the value is also string. But this string is a topic name and this one is a data. Okay. So here, I just have to make this as booking DTO. Yeah. So now what I need to do, I will just go to the booking service MPL, and here I just have to pass the booking detail. Okay. So here what we are actually doing, we are actually pushing the booking details to the payment request topic. Okay. Now what happens? So here I just wanted to write some logs, SLF4j. So log.info, and so publishing booking details to payment request topic. Okay. And then probably what we can do, we can simply, I can simply go to this booking service NPL. Instead of using the object mapper over here, I can simply go to this. So instead of using AutoWire, we can simply go and keep at the rate. So let me declare this as final. This is the best practice. Okay. And fine. And we need to generate a constructor, otherwise it will give an error. So for generating a constructor for final fields, we use required args. Okay. So that's it. The issue is resolved. Now we'll just go to this one, and here I will just use a try catch block. Okay, and here I just wanted to use um, log.error while publishing the data to the payment request topic. That's it. Okay. And now here, what I just wanted to do, instead of using @auto-void, I can simply declare it as final. And then I will just make it as required args constructor. So required args constructor will generate a constructor only for the final fields. And this is the best way to object mapper. And here we do have the object mapper. That's it. Okay. So this is a final field. So probably we will be, generating a constructor for this final field. Okay. And then it will generate a constructor. So we don't have to do auto wiring because this is a constructor injection. So constructor will inject the properties from the application context factory and initialize these two properties. Okay. How this property will be initialized based upon the application.yaml that we do have over here. So based upon this, it will generate a Kafka template. Okay. So why I'm using a string serializer and JSON serializer, you will know in a bit. Okay. So now what I can simply go and do, I can just use this dot Kafka template dot. There is a method to send the messages. So here I can just give two parameters. One is for the topic name. What is the topic name? If you just go and see, the topic name is payment request. So just copy this and paste it over here. And the next thing is we need to send the data in the form of string only. So here, that's the reason I have actually given in the application.yaml, the key serializer is a string and the value serializer is a JSON serializer. But here itself, I'm just giving the object mapper. This is basically from the Spring framework, and I'm just going to convert this booking details, right, value as string. So this booking detail will be converted to the string. So this string will be a JSON string. That's the reason inside the application.yaml, and I have just given it as a JSON serializer. Okay, because if you just see here, booking service Kafka publisher, this JSON will be generated in the format of string, but inside the string, it's complete a JSON structure. Okay, so that's the reason I have not given string serializer again. I have just given JSON serializer for the value. Okay. Now, why this is from Apache Kafka and why this is from Spring Framework? Because we are using Spring Framework object mapper in order to convert that string to JSON. But here we are simply giving a string, so we can use string serializer. Otherwise, we can also use string serializer over here. But inside the string, we do have a JSON. So that's the reason I have actually picked up JSON serializer from the Spring Framework itself. Okay, that's the total idea. And here, now let's see whether we are going to send the data to the payment request topic. But there has to be a subscriber, right? So let me go and write a subscriber inside the payment service because these details are to be received by the payment service itself. Got it? So that's the total idea. Now what I will simply do, 1 second. Okay. Okay. So now I will just go to this payment service. And here I need to define some parameters over here. So here, basically I will just go to this and source. We have added Kafka over here. Yes, we have added it, and we will just go to the main resources. So this is acting basically like a subscriber, right? This is a consumer right now. So let me go to this application.yaml and enter it here. And there is a Kafka. And here, what we need to do, we do have to mention a consumer and the Bootstrap servers. Bootstrap servers are the same. So I will just go to the booking service. For producer and consumer, Bootstrap servers are same. Okay. I'll just copy paste it over here. That's it. And now, since this is a consumer, we cannot use the serializer, right? This is a deserialization because when we produce the data, we actually send the data by serializing it. When we consume the data, we actually deserialize it. Okay, so we can actually use a key deserializer. Okay, and key deserializer is basically from Apache Kafka. So I will just go and string deserializer, and this is basically from Apache Kafka. You can just go it over here, string deserializer. Yeah, string deserializer from Apache Kafka. So you can just copy the package over here and string. Just copy paste the name. If it is wrong, then it will not work. And value deserializer. Okay. And value deserializer is JSON deserializer. So here what I can simply do, JSON deserializer. And this is from Spring Framework. JSON deserializer from Spring Framework itself. Sorry, this is not the one. This is the one. So copy this package and paste it over here. Dot JSON deserializer. That's it. Okay. So now we have the consumer inside the payment service. So now what I will simply do, I'll just go to this Java package, and we do have a publisher over here. I'll just create a listener package also. Listener, and make this here. That's it. Okay, we'll see that publisher later on because right now this is a listener. So if I just go to this one, so I have actually written a listener yesterday, right? Yesterday in the class. So here, this is a payment service Kafka listener. So what it basically does is whenever data is coming to this payment request, that means whenever some data is pushed to this payment request topic, then this listener continuously listens to this topic, and this group ID is basically acting like as a subscriber. I just wanted to give this as group one. Okay, I'll tell you about this group ID, but not right now, maybe later on. Okay, just after 5 to 10 minutes, I will tell you about this group ID. And here, what I can simply do, I will just use at the rate SLF4J, and basically I will use log.info, and I will just mention it as received booking details, or here we can actually pull data, pull booking details from payment request topic and received booking details from the payment request topic. And here, I can simply add a placeholder, and here I can just give the booking details JSON. That's it. Okay. So let's see how this is actually going to work. Let me start the payment service application first. Sorry. Let me debug it, and let's see what happens. So first we need to register this subscriber to the payment request topic. It will give you that subscription details also. I'll show that to you right now. Okay. Yeah. So this will fail because the Eureka server was not up and running. But here I will show you something interesting. Okay. So here, can you see this? Payment request group one. For this group ID, the partitions are assigned. What are the partitions? Payment request 0, payment request 1, payment request 2. These are the partitions. Okay. So let me clear this logs. Now it is being assigned properly. Now I'll stop running the payment service application and I will start the Eureka servers application. Okay. But right now I just wanted to remove two running instances. One is this one. I can just remove this. I can just remove this one as well. I think, okay. Movie services registry application. I will start this application because that is the first application that we need to run. Okay. And then we need to start the API gateway because API gateway is only the application which can route our request to the booking service. Okay. Let me start the API gateway also. And once this API gateway is up and running, then probably we can actually start our booking service. Okay. And we can clear this all. And we can actually start our booking service now. We can start our booking service. So we don't have to worry about this ports because API gateway will call the service directly with the service name. Okay. So you don't have to worry about this. So now, okay. So I just wanted to start this booking service application in debug mode. Okay. So let me start the booking service application in debug mode instead of starting it in learning mode because we need to see what is happening behind the scenes, right? So I'll just go and keep a debugging point at the booking service IMPL where it actually publishes the data. This is a place, correct? So now I'll just debug this application right now. Debug this booking service now. Right now, the payment service application is not running. Okay, we'll see what happens. Okay, so clear this, and now what we can simply do, we can just go to the Postman. Okay, so here I just wanted to send this data. Why method not allowed? What is happening? So why the method is not allowed? This is post mapping, request body is booking DTO, and we are actually sending all these details. User ID is being sent, movie ID is being sent. What is the meaning method not allowed? We were not getting it right previously. 8765 is the port and forward slash bookings is the one. Let me go to the booking service first of all. Okay, let me use 7070 directly in order to explain the things in a better way. Okay, so now it has received the details, but why it is not coming from the API gateway? But we will see that later. First of all, let's concentrate on this one. Okay, so we have received the booking details over here. right? We have received the booking details along with the booking status as pending, because already in this, I have not kept a debugging point. Okay, so here basically it is going to save the booking entity along with the pending status, and it is going to send the details to the payment request topic. And here we have received the same details to actually publish this data to the payment request topic. Okay, now I just wanted to forward this request, and now this is a place where I have mentioned the topic name, and I have actually converted this class to a string JSON. Okay, so let me execute this and see what happens. Good. We don't have any issues. The data has been published to the Kafka topic, and just finish it from here. And here we were actually getting the response as pending. That is totally fine. Now we will just start our payment service. The payment service is not up and running, right? So we'll just start the payment service also. Now, the moment the payment service is up for at least 5 to 10 seconds of time, it is just going to process our data. Okay, so let's see what happens over here. So let's see the logs. Yeah, can you see this? Yeah, can you see this one? Received booking details. The moment the payment service was not up when the booking service published the data to the payment request topic, but there is a Kafka listener where it continuously listens to the topic. And once the details are subscribed, then only we will be getting this data. Okay, so can you see this? These are the same details which are published to the Kafka topic. The moment it was up, see, payment service will not be down for a long period of time, because so many people will be sending all the credit card details and all these kind of things, right? In real time, we will not be there will be no much downtime for the payment service. Let's say for 4 to 5 seconds, or 5 to 6 seconds, or 5 to 10 seconds maximum. If it is not available, then the payment service has to process this data. Otherwise, there will be a revenue loss, right? That's why we need to capture all these data, and then probably we can process the data and give the response back to the user. Okay, so now we have actually received the details over here. Okay, so now let's understand what is happening. Okay, so here inside the bookings, inside the payment service, now payment service is acting like as a consumer. So here, if you can see it over here in the resources, this is a consumer, and this is a deserializer and a value deserializer. Now I'm not doing any deserialization. I was just receiving the details over here, because here the deserialization will be performed by the Kafka. Okay, that's the reason we have actually given this kind of thing. Okay, so now if I just go to this payment service listener, Kafka listener, payment service Kafka listener. So we have received the booking details from the payment request topic, and this is the details that we have printed. But we need to, use these details in order to save the information and make a call to the Stripe payment gateway in order to do the payment for the amount that we have passed. Okay, so that's the total idea. Now, what we need to do with these details, but let's understand what is happening behind the scenes. Okay, so there is one Kafka listener right now, and what is this group ID? Okay, so let me explain you one simple scenario. Okay, so there is a new YouTube channel. There are no subscribers. I am the first subscriber to the channel. Okay, now when I have subscribed to the channel, I'm the only subscriber. When there is a audio content or any content or video being posted by that particular channel, I'm the only subscriber who will receive the data. Correct? Now, what happens if there are multiple subscribers? Let's say there is another subscriber coming in, and basically what happens is he will also get the notifications. But let me explain this particular scenario. Okay, so right now I do have the payment service Kafka listener, right? I just wanted to create another listener, payment service Kafka listener 2, and here I will just copy the same content over here as well. But here I cannot mention the same group because group IDs are unique. So group IDs are basically subscribers. Let's say my name is Srinivas. I have subscribed with my Gmail account or whatever the credentials that you do have. I have subscribed to a channel by logging into the YouTube. Now there is another subscriber who is subscribing to the channel, but already the notification is released for the first subscriber. When I will mention it as group 2, this is the second subscriber who will receive the notifications from the payment request topic. Okay. Now, if I just stop the application of the payment service, and if I run the payment service application, now this payment request group 1 has been already registered with the payment request topic. Already the data is being consumed by this consumer, right? Subscriber. Now, this person has not got the notification, but this subscriber has subscribed to the channel after the video was released. He will not be getting a notification, correct? Because he is the new subscriber. Now, if you can see that over here, payment request group 2, now the partitions are assigned. Now, when there is a new data coming in from the payment request topic or from the YouTube channel, let's imagine, right? So now I just wanted to clear these logs. And now I just wanted to make this down for some period of time. I will just submit the booking details right now with A1. Good. And now I just wanted to change the user to test user. And seat is A2. Now I can just send the data and I will just end this request. Now what happens? Now I will just go and make the payment service up and running. I will just go to the payment service and start the payment service now. The moment it was down for 5 to 10 seconds of time, the moment it was up, it will just process the records, whatever it has missed, because it has the revenue. It doesn't have to lose the data. It has to process the request so that the company will be getting a lot of money, right? So that's the total idea. Now it will process the records. Can you see this? Now both the subscribers will get the data. Can you see this? Let me copy paste this content. So I have already pasted it for the users already, because for Spring Batch, for Spring Boot microservices AWS batch, so already have explained this in the morning session. So let me explain this one as well. Now, okay. So here I will just remove all these informations. Here also I will remove it. Okay. So now, can you see this? This is a subscriber 2 and this is a subscriber 1. So both are going to receive the data. Same data published by producer getting this 2 different subscriber, which is having 2 different group IDs. Yes, because see, Akash, you and me are the subscribers for a channel. Okay. Whenever they are publishing some audio content or video content, okay, you and me will get the same notifications, right? Correct or not? Same thing happens for the Kafka also. Here, the group IDs are basically acting like subscriber IDs. Can you see this? This is having a different group ID and this is having a different group ID. Subscribers cannot be same, right? A subscriber cannot subscribe the channel again. There is only one-time subscription. Okay. So once the subscription is done, then only these 2 subscribers will get the data. So that's the reason we are. And when I start this application again, So here group ID is acting as a subscriber ID. Yes, exactly the same. Think like that. Okay. Think like that itself in that particular scenario. Okay. Because I'm telling in terms of YouTube subscriptions, and it also works well with the group IDs over here. So if you just wanted to create multiple subscribers, then the group ID has to be different. Imagine what happens. This is not, we cannot maintain two subscribers because there is no need here. But when the payment service has processed the amount, that means the Stripe payment was successful, it has to respond back to two different services. We have not included notification service right now, right? So the booking service has to be invoked and the booking details confirmed has to be saved inside the booking database table. And now the other thing is, whenever there is a notification service, booking service and notification service has to get these response from the payment service that the payment is done, so that booking service will do its job. That means changing the payment status from the booking status from pending to confirm, and also notification service will trigger a notification email to the subscribers. That means the end users finally. Okay, so that's the total idea. Got it? So that's the benefit of using this group IDs, but we don't require this. I have just explained you how this actually works. The group IDs are going to work. Now, let me tell you how it is actually working behind the scenes. Now, when you say Kafka listener, so this Kafka listener listens continuously to the payment request topic, and then it has a subscription ID. That means in Kafka, we call subscriber as a group ID. Okay? Subscriber ID as a group ID. So that's the total idea. So right now, if I just wanted to stop this application and restart this application, do I get the notifications again? No, because already group ID 1 and group ID 2 has already got the details. It will never get the details again when we restart the application because that data is already consumed, correct? Now see this. Started, and now we will not be getting the details again. Okay, got it? Okay, that's it. That's the only thing about this group IDs. Payment service playing role as subscriber as well as producer also. Yes, right now it is acting as a consumer. Okay, it is acting like as a consumer, but again, what it has to do with this booking details, it has to send this booking details information to the Stripe payment gateway, and we require only one attribute, which is amount. We need to pass this amount to the Stripe payment gateway, and Stripe payment gateway has to succeed in booking the details. Okay, so now what it has to do, it has to pass this details to the, in case of notification and booking, so there will be a payment response topic where after successful payment, it has to send back the booking status as confirmed to the booking service as well as the notification service. So notification service has to use a different group ID, and booking service has to use a different group ID, okay, for the payment response topic. So that's how it actually works. But we'll see. Don't worry about that, okay? Yeah. So now I'll just remove this extra listener. So any doubts in this, first of all, anyone? Any doubts in this? Okay, from your side, Akash, it's fine. Suresh sir, ah, any concerns in this, Suresh? Do you have any questions? I think everyone understood the point, right? Only practical things will make a lot of sense. Theory will not make any sense, okay? So even we need to cover theory as well, because until unless it is not being understood by so many people. Shall we use multiple payment request group IDs? Shall we use multiple payment request group? What is this, Ashok? Can you just raise your hand? Can you just please unmute?
Yeah, yes, sir. Shall we use payment request group ID one only in real time? We can use only one or multiple.
What?
In real time, shall we can use payment request group IDs only one or
See, right now in this case, it is not required, right? I was saying that if there are, see, right now that is not required. So here, this is not required at all. What I'm saying, let's say this has received the booking details, correct? Hello, Ashok. Ashok, are you speaking? I cannot hear your voice, Ashok. Ashok, what happened, buddy? Okay, let me unmute Suresh. Hey, Suresh.
Yeah, one simple question. Like you showed, right? Like consumer will be consuming the data, right? So let's say the server is down, the producer server is down for some time, and that time consumer will not receive the data, right?
Yes, of course,
After.
that is.
So
But
once this is up, then it will receive the data, right? So
yes,
when it
yes.
receives the data, then
But
data is lost.
here, see, what I'm saying, Suresh, if Book My Show application itself is not up and running, what happens? No one can send the data, correct?
Yeah,
No
correct.
one can book the ticket. Like the same way, our first priority is booking service has to be up and running at any cost. So what we will be doing right now, we are actually using Kafka clusters between booking service and the payment service as a mediator. So that payment service will receive, because payment has to be done at any cost. The payment service cannot be up, cannot be down for long period of time. Correct. In real time, payment service might be down for 5 to 6 seconds or maximum 10 seconds, so that there will be a lot of reloading happens behind the scenes, correct? Something can happen, but it cannot be down completely because they will be running each and every service inside a cluster. So right now we are actually sending the data to a topic, and that topic has a subscriber, that is the payment service right now. Okay, now why we are using cluster over here? Because cluster makes sure that there are a lot of brokers also, right now we do have 3 different brokers. Even if one broker is down, the 2 available brokers are still there, and still they will be still they will be having the data for the payment service consumers, so they will be getting the data at any cost. But what I am saying, when the booking service itself is down, people will not be able to send any kind of request, right? So we need to make sure that booking service has to run inside a cluster. That means we can use Kubernetes cluster to make the booking service always up and running. There will be no crashing over there. In real time, we will be doing that. Okay.
So once the data is consumed, then we lose the data, or
Yeah,
we have to
we
send.
lose that
We'll
data. We
send.
lose that data because the subscriber has, see, you have subscribed to YouTube channel. So let's say you got notification, you logged out and you log in. You will again getting a notification or you will not be.
No, we'll not get again.
See, let's say a simple example. Let's say you just go to a bank ATM, you just draw your amount. So how many times you will be getting the notifications? Only one time, right? The
Yeah,
same day.
correct.
Once you got the SMS, then probably it's done, it's closed. But
Okay.
there is a possibility that we can actually replay the messages to reprocess the records. There is something that there is one field inside Kafka also. So let's say we have lost our database records. Okay. So in that case, what happens? We have something called, there is one field. There is something called auto offset reset. So there are auto commit intervals, there is auto offset reset. What is this auto offset reset? So there are some values for this. Okay, so one value is earliest. So when you keep this, okay, so you'll get the data every time. But this is not required in real time because let's say there are 10 messages. Can we get 10 messages every time when we start the application? That is not a right approach. But this can be used when we are actually losing the database records and we need to do some auditing and reprocess the records inside the database, right? So at that time, this thing is very helpful. But this cannot be used in real time. Got it?
So fault tolerance is like when let's say there are multiple consumer and one
Consumers
consumer.
fault tolerance mechanism is not available because fault tolerant mechanism is applicable only for the Kafka brokers. See, when the broker 1 is down, still it can serve the request, right? How? From broker 2 and broker 3. There is a fault tolerant because we are actually
Producer.
providing a fallback mechanism where other brokers can still serve the consumers, correct?
So that means you are saying if the producer is down, then other producer can produce the data.
No. I'm saying about the brokers. Fault tolerant mechanism is applicable only for the brokers. Why I said brokers? Because brokers are the ones who are going to, have a complete control on the storage as well as on the topics, correct? Now, brokers will have there is broker 1, broker 2, broker 3 right now, all right? So let's say broker 1 has the data, broker 2 also has the same data, and broker 3 also has the same data. Why we are maintaining it? Let's say if the broker 1 is crashed, the data is still available for the consumers from broker 2 or broker 3. The zookeeper will let the consumers know that, hey, don't worry, there are 2 available brokers. I will make any one of the available broker to you to subscribe the data. That's it.
So you mean to say one server crashes, then data is available on other server, B2, HA,
These servers are actually Kafka brokers.
But producer has to be up and running all the time.
Yeah, producer has to be up and running all the time. Yeah. See what happens. We see the basic idea is when the book my show itself is not up and running, we cannot send a request, right?
Yeah.
We need to maintain some mechanism. Let's say book my show is up and running. The payment service was not up for 5 to 10 seconds of time. In that 5 to 10 seconds of time, might be it has received 1,000 requests or 2,000 requests. It has to reprocess that, right? Otherwise, there will be a revenue loss. In that case, it will be helpful, right?
Yeah, correct. Because we'll have intermediate data is stored temporarily.
Right,
somewhere.
exactly the same. Yeah.
These servers are like they're on-premise server or they're like cloud servers.
See, basically, we are not running Kafka inside our local machine, correct? To set up Kafka in our local machine, it almost takes, I think, 1.5 hour time to set up for installation itself. You know how much time it takes for OS installation? Okay, it's the same for Kafka also, but it's not recommended to install Kafka. Basically, there are some images already provided by the Confluent Inc. So Confluent Inc. is the organization where they have provided some Docker images so that we can use it to run Kafka in our local machine. Okay, so if you can see this, there is a Docker Compose file where they have given all these services. I have not written it from the scratch. These services are already available over here. There's a schema registry, see here, right? That's it. They have actually given the steps to, run the software on your local machine through Docker images. That's it.
So these blockers are kind of on cloud, right? Like we don't
Okay.
have control.
Now, can you tell me where Kafka is running?
Right now in local machine.
No, they're running in local, right? They are actually running in Docker Cloud.
Oh, Docker Cloud.
Yeah,
Okay.
they are running over here. It is not
correct. And that is exposed to the
our local machine. But the Kafka is being accessed in the Docker Cloud. But that is exposed to our local machine. We can still call it from our local machine. That's it.
So in any organization, it always runs on cloud, right?
Yeah, it always runs on cloud.
If they don't have Dockers, then where it runs?
See, right now, where I'm running these images in my local machine, right? If I deploy my application on AWS Cloud, then probably our application will run on AWS Cloud only. if I just wanted to access the booking service in AWS Cloud, then probably local host will not work. There will be some host name or the URL, right? That is how it will be accessed.
Yeah, so that may not be Docker. It can be in any other
It
cloud.
has to be Docker. It has to be Docker because Docker is providing this open source related software. Where do you want to use it then? Docker is the provider, right, for this.
So if let's say some organization doesn't use Docker, but still they want to use Kafka. So they can use it, or they need to have Docker.
See, normally the recommended way in each and every cloud, we do have Kafka. Okay. In AWS also, we do have Kafka. In Azure, we do have Kafka. And in GCP, we do have Kafka. All those are Docker images. Those are Docker images private to the AWS cloud, not to Docker Hub.
Oh, got it now. Okay. So already Docker is providing images and different.
We need to use it. Why we need to recreate the software, right? So let's say right now, MySQL Workbench is running on my local, right? But how we can actually create MySQL database for if you just go to AWS, there is RDS database. We don't have to use MySQL because it is a SQL database. We can use it and we can give the URL. Instead of localhost, we can give IP address followed by 3306/database name. That's how we give it, and it will connect to the AWS cloud. Got it?
And another question is on side note, like how will be creating our integration test scenario based on this? What are the different integration point? So Kafka server.
Did I discuss about integration test right now? What is our focus right now, Suresh?
Yeah, I understand. Yeah, the Kafka things. Yeah.
When the time comes, we'll let you know, man, why you are concentrated on testing, especially.
No, I'm trying to see the integration point.
When the time comes, I will tell you, not now. Okay. We have not completed Kafka. Why we can go to some other task and do it?
Yeah, okay.
We have not established the task completely, right?
So we'll have separate session on it. Okay, thank you.
Yeah. There are some questions from sir. After subscribing the data by subscriber from topic, then the subscribed data will be deleted from the Kafka topic. Yes, of course. Or it will be there inside Kafka. See, the deleted means it will be still there in the Kafka topic, but what happens is, let's say there is a new subscriber. The subscriber, if the subscriber new subscriber has to go get the data, the data is still available in the Kafka topic. Okay, Akash. So it's not something like deleted. We can actually replay the messages. The data is still available in the topic. Got it? Akash. Yes, tell me, Akash.
Yes, sir. Good morning.
Good morning. Tell me.
Yeah. Sir, the scenario is like publisher publish the data. Okay. Suppose 10 records, or we can say 10 objects will be published by one publisher. Okay. So payment service is there. Payment service initially three objects subscribed. Okay.
No, it is not something like that. It will get all the records because that is the subscriber, right? It has to
or the scenario is like initially our producer published 3 records. We can say 3 objects. Okay. So payment service subscribed those 3 objects. Okay. After that, due to some reason, payment service is down. Okay.
Yeah.
So in that time only, our producer published another 7 records. Okay, so total is 10. So after some time, payment service is resumed. So how this scenario is handled by payment service means already
once it has consumed the first 3 records, the moment it was down after consuming the records, but the data has not been inserted into the payments database, right? So we will call that records as auditing records. We need to audit because once that, see, sometimes we do the payment, but our money account gets deducted with the money. But later on, after 6 or 7 days, our payment will be reprocessed to our bank account again, right? Those are considered as error scenarios. In that case, what happens? So they will have all this kind of details, right? So right now, the booking status has not been changed to pending unless the payment service responds with booking confirmed status, right? So what they will do, they will actually run auditing on the booking service table. They will get all the pending related booking service details, and they will also see that, hey, amount has been deducted for this particular user. And the payment service has not responded back to the booking service with booking status as confirmed, right? Those are error scenarios. How these scenarios will be solved? These scenarios will be solved where it has to reprocess the records from the topic again. And for that, we do have a special flag inside this. And this is where auto offset reset will come. So what it will do when we place this one, it will get all the 10 records again. Okay. The 7 records were successful, but the previous 3 records were failed, right? So in that case, it will reprocess that 3 records and issue a refund for those particular customers.
Okay.
Okay. But that is a very hard scenario. We cannot implement that right now. So
Yeah.
I just wanted
to asking, sir. In last time, one interviewer asked me about this. That's why.
Okay. Yeah. So basically, we will be having, the auditing where we will actually process. See, every midnight there will be a scheduler which is going to run for the pending status of the booking tables. Why that status has not been changed when the payment service has done with the payment, but it has not replied back to the payment response topic. So the booking status will never be confirmed for the end users. Correct?
Okay.
Right. In that particular case, they have to reprocess this record. There will be a scheduler job. There is something called a cron job, which we will see it later in our major project. I will tell you when we need to use that cron. Okay.
Sir, is there any flag? Means the if payment service subscribed one object from the topic, so is there any flag for that subscribed or like that?
Flag in the sense what?
Flag means if in the topic there are 10 objects. Okay, so from that 3 are already subscribed by the payment service. And once the service is resumed, okay, so the another 7, just I want to consume that another 7 only, the next 7 only, not already subscribed.
Yeah, in that case, we do have something called latest.
Okay.
Yeah. We do have everything for that. Okay.
Yes.
Yeah. So that's the total idea.
Thank you.
Yeah, but very good questions, Akash. Okay. Yeah. It makes sense. And who is the other person who raised his hand? Any other person? I have seen some person raising his hand. Naresh. Yes, Naresh. Tell me.
Actually, I was only Akash asked some questions, and my side, you see, if locally, if you want to run, sir, in the YAML file, if you run in the Docker, it will create the image, right? And if you start from run in the Docker, if you run, if the URL also, we can run it in our browser, right?
Yes.
From browser also, we can create a topic.
Yeah.
Like local, if you want to
create a topic, yeah. But that is not the recommended way. We actually write scripts. Okay. So we don't give permissions for the users to create topics from the UI. That's not the recommended approach. Okay. So here we can actually create the topic. So here there is a create topic option also. But that is not the recommended way. There are scripts to create topics. Basically, this will be unauthorized. That means forbidden access. No one can create topics from the portal itself. Okay.
Okay, sir. So another one is you said like payment service is down, but they will get multiple requests, like 100 requests for the payment. Who will behave like a publisher, sir? who will behave like publisher?
See, booking service is a publisher right now to the payment service, right?
Okay.
But payment service is a consumer, but again, it has to act like as a producer also, because once the payment has been processed, it has to respond back to the booking service also, right? There is a payment response topic for that, where booking service will act like as a consumer for the payment response topic.
Okay.
See,
So
booking service is calling payment service. How? Through the payment request topic. So payment request topic subscriber is payment service right now. Once it process completes, the payment is successful, then again it has to respond back to the booking service, right? Otherwise, how the booking status will be changed from pending to completed or confirmed.
yes.
So here booking service is acting like a producer, but later on it has to act like as a consumer, because payment service will again act like as a producer for the booking service through the payment response topic.
Okay. Yeah.
Got it? So we'll just see that scenario tomorrow. Okay?
Okay.
It's a very reverse way, and also once payment is processed, not only the booking service has to act like as a consumer, we need to introduce one more consumer, which is a notification service, to send an email. Got it? So here we need two subscribers. One is the booking service for payment response topic, and also notification service for the payment response topic. Why? Because booking service has to change the status from pending to confirm, and notification service at the same time it has to send an email. Correct? So we'll see the scenario tomorrow. Okay?
Yes, sir. Sir, every day you are concluding. Is there a small request concluding the session? Just 5 minutes. Can you give the brief, sir? What you tell in the session? Just concluding 5 minutes. Is it fine?
So conclude in 5 minutes. What?
Sir, see, you given that session like 1 hour, right, sir? So before concluding the session, 5 minutes for the overview. What we have discussed 1 hour. 1 hour.
That's what I said right now to do. That's what I said to do, Ram.
Yeah.
What we have done and what we are going to do tomorrow.
Okay.
Do I have to repeat it again? Huh?
Yes, sir.
Anyhow, I am repeating a lot of things every time, right?
Yeah. Great.
Okay.
Yeah.
So I just wanted to give this application to you so that you can also have a taste of it. Run this application in your local machine and let me know in case of any concerns. Okay. I just wanted to share this application right now with everyone. Just go to the infrastructure. I'll just remove this. Let me stop this applications all. And go to the volumes. This. There's a real-time batch too, right? Okay. So every time you need to remove this, otherwise things will not work on your machine. Okay, this is specific to my machine, right? I'm just removing all these things and I will give it to you. Okay, let me close this one because Docker containers are running, right? Let me delete the containers. Don't delete the images because it will take a lot of time. And if you just see the image sizes, I will tell you how much size it is actually giving to you. Yeah. So here, can you see this? Confluent Inc., the Kafka cluster is 779 MB. Schema registry is 1.64 GB. Zookeeper is 779 MB. And this is almost 427 MB. So if you just consider it is almost 2.5 GB. Okay. So it is not almost 2.5 GB. It is almost 3 GB plus. Okay. So we do not recommend installing this big softwares in our any environments like AWS Cloud. There are Docker images and we can use it. Okay. Let me give this application to everyone. I just want to give everyone this empty so that everyone can run the Kafka successfully. Okay. So this is the one, and I'm just giving this as a zip file to everyone. So before that, I just wanted to remove the target folders also because they will not run because it will contain a huge size. So that's the reason I'm just deleting the target file because this will be generated specific to your machine. Okay. Show more options, 7-zip, and this one. So let me give this application to you in the Telegram channel. I can give it in the chart itself. So let me attach the document. Desktop, workspace, Streamlabs, real-time batch 2, and so I just wanted to rename this to Kafka Docker basic code because the code is not completed yet, right? Yeah. So let me share this to you, everyone. And also I'll just share it in the Telegram app also. I can go to this one and I can simply give the file. Batch 2, the basic code. Okay. I think everything is clear to everyone. Okay. Fine then. Have a great day and I will meet you tomorrow in the same time. Okay. Bye and have a great day. Akash, tell me Akash, sir. Wait for
No,
some
nothing,
time. Wait for
sir.
some time.
Nothing, sir, nothing. Actually, I forgot to unraise my.
Okay, fine. Yeah. Thank you, Akash.
Thank you.
Bye everyone and happy learning. Bye.